So how do you solve that? Say you want to come up with 95% confidence interval. You want to come up with the 95% confidence interval. Say you have come up with a interval which is 23 degrees Celsius to 30 degrees Celsius, assume. This 95% is nothing but 1 minus alpha. So what is alpha? Alpha is equal to 5%. What does this mean? There is a 5% chance that temperature can either be less than 23 degrees Celsius or greater than 30 degrees Celsius. Since this is a normal distribution, standard normal distribution, and since this is symmetrical, there is an equal chance of temperature being less than 23 degrees Celsius or greater than 30 degrees Celsius. If there is an equal chance, what does that mean? Out of 5%, equal chance means 2.5% and a 2.5%. Means there is a 2.5% chance that the temperature could be greater than 30 degrees Celsius, and there is a 2.5% chance that temperature could be less than 23 degrees Celsius. So you have come up with this interval. But in reality, tomorrow's temperature might go wrong also. Might not fall within this range. And what is the probability that it might not fall in this range? 5%. Since it's symmetrical, there is an equal opportunity of temperature being greater than or less than your range or interval estimate. Now, given this probability, 95%, 2.5%, 5%, all these are probabilities. Given the probability values, if you want to calculate the z value, then you need to do this, right? You know for a fact that when you calculate the probability, it will calculate the entire region towards the left. So if you traverse from here until here, you have 95%. And from here until here, you have 2.5%. So if I combine these two, it is 97.5%, which can be written in number format as 0.975. Now we will try to solve this using R. Yeah, using R, the function is Q norm. In the previous tutorial, z value was provided to us, and then using z value we have calculated the probability value using P norm. But here we're using the other way around. So let us try to do this using R. So it's nothing but, let me choose this. It is Q norm of 0.975, and you get 1.959, right? You can round it off to 1.96 roughly. This is a universal value. You need to by heart this. Since this is the first time we are doing a manual calculation, in the real world, you never manually calculate these. So you need to by heart this, that the z value at 95% is equal to 1.96. Alright. What if your management walks up to you and says, hey, I want you to come up with an interval estimate for the sales or for the temperature with 90% confidence? Then once again you need to construct that. You need to calculate that for 90%. Assume that you have come up with temperature as 23 degrees Celsius and 35 degrees Celsius. Yeah, just assume for now. What does that mean? Tomorrow's temperature would fall within this range 90% of the times. So there is a 10% chance that the temperature might either be greater than 35 degrees Celsius or temperature might be less than 23 degrees Celsius. But since this is a standard normal distribution, it will be symmetrical. symmetrical across the mean. Hence, there would be an equal chance that your temperature might be less than 23 degrees Celsius, and also there would be an equal chance that the temperature tomorrow can be greater than 35 degrees Celsius. So there's a 10% chance that it might fall beyond the interval that you have provided. So since there is equal opportunity, there is a 5% chance that temperature might be less than 23 degrees Celsius. And there is a 5% chance that temperature can also be greater than 35 degrees Celsius. And you know for a fact that by default, if you have Z value by default, you can calculate the probability, but it will calculate the complete region towards the left by default. And from this probability, you want to get back the Z value. So once again, you need to consider the entire region. So from here until here, you have 90%. And from here until here, you have that 5%. If you add these two, it is 95%. And 95% is equivalent to 0.95. Now, once again, I go back to R. And we can solve this here. It is Q norm. I'll do the up key on the keyboard so that I go back to the previous function. It is 0.95. I get 1.64. This is a universal value. You need to by heart this. So the Z value at 90% is equal to 1.64. And Z value at 95% is 1.96. You need to by heart, right? Because we will not go back and keep doing that. All right. What if your management comes up to you and says, hey, I want you to come up with an interval with 99% confidence. So maybe you come up with the temperature saying that the range is 25 degrees Celsius to say 30 degrees Celsius. And you're constructing a 99% confidence interval. This means that there is a 1% chance that your temperature can fall beyond your range in reality. And since this is symmetrical, there is an equal chance that temperature could be less than 25 or greater than 30 degrees Celsius. Equal opportunity means there is a 0.5% chance that temperature might be less than 25 degrees Celsius, or there is a 0.5% chance that temperature could be greater than 30 degrees Celsius. As you know, we need to consider the complete region towards the left. By default, that is how it works. So from here until here, it is 99%, and from here until here, it is 0.5%. So this is equivalent to, if I sum up these two, it will be 99.5%, which is equivalent to 0.995. And now if you calculate, Q norm, I press the up key, it is 0.995. You get 2.575. You can round it off to 2.58. All right. So those are the values which you'll have to by heart. So Z 90% is 1.64. Z 95% happens to be 1.96. And Z 99% happens to be 2.58. Now we will actually try to construct the confidence interval. Yeah, we will try to construct a 95% confidence interval now. So you're coming up with an interval, right? So you're telling I'm ignoring this side. No, I'm actually not ignoring any side basically. We are coming up with this. So the formula is x bar plus or minus z1 minus alpha sigma over square root n. this plus or minus is taken care of. So if it is 0.975 here, you get 1.96, right? Now, if I do Q norm of 0.025, yeah, I would get what? Minus 1.96. That value, minus 1.96, is actually included in that formula called plus minus z1 minus alpha sigma over square root n. Now is it clear? This plus minus actually includes this scenario. Hence we have not calculated this separately, not required. Okay. That's a good question actually. Alright. Now let us try to solve this. The sample size is given to us as 140 in the question, in the case study. Population standard deviation is given as $2,500. Sample average is given as $1,990. And what is the formula? Formula is as follows. X bar, my bad. One second. Yep. So it's X bar plus or minus Z1 minus alpha into sigma over square root n. If you want to expand this, it'll become X bar because we need to come up with an interval estimate, the minimum value and the maximum value, right? So the minimum value would be X bar minus Z1 minus alpha sigma over square root n, and the maximum value would be X bar plus Z1 minus alpha into sigma over square root n. Now we can solve all these. X bar is given to us as $1,990, so 1990 minus Z value at 95%. 1 minus alpha here is 95%. So Z value at 95% is what we have already solved as 1.96. And you multiply it by sigma over square root n. Sigma over square root n is already solved here for us. Sigma is 2,500 divided by square root of n would give you 211.29. So that value directly I'm substituting here, 211.29. And here you have X bar plus Z1 minus alpha into sigma over square root n, which is 211.29. And if you all are wondering on Z 95% is 1.96, but one very good question is when you construct this interval, you're calculating Z value at this location, right? That is 95% plus 5% or 2.5%, right? What about this remaining 2.5%? We need to consider this also. And under such a scenario, it is Q norm of 0.025, which would consider the other side. And here it is 1.96. Here it is minus 1.96. So you'll get those values. If you solve this, you would get the minimum value and the maximum value. It's called as lower range and upper range, and that is your interval, 95% confidence interval. On similar lines, you can solve for all the different scenarios possible. Let us solve this for 90%. Formula remains the same. It is X bar plus or minus Z1 minus alpha sigma over square root n. And if you want to expand this, it is X bar minus Z1 minus alpha sigma over square root n. This gives you the lower range or minimum value. And x bar plus z 1 minus alpha sigma over square root n would actually give you the upper range or the maximum value. So we need to just solve these values which are there in the case study. Average balance was given to us as 1990, so it is minus. Z at 1 minus alpha. 1 minus alpha is given as 90% here. So Z at 90% is going to be 1.64. And sigma over square root n is already solved for us as 211.29. This will give you the lower range, and 1990 plus 1.64 multiplied by 211.29 would give you the upper range. And you can just solve that. All right. And towards the end of tutorials, you'll have assignments, and you'll have an assignment for 99% confidence interval. And there are a lot of other additional assignments which will ensure that all your learning until here, or till simple linear regression rather, is tested. So you'll have to solve those assignments for better understanding.